Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 8 to the power of n minus 4 to the power of n is equal to 18, and we will solve this problem for the values of n. So the real values of n. Here you remember one thing is that we can solve this problem for the real values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have 8, we can write it as 2 cubed and its whole power n, minus we can write this 4 as 2 squared and its whole power n is equals to 18. And after this step we can use here the nice exponential law. So you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of m to the power of n. It means that if you have exponent to the exponents, then we can interchange these two exponents. Sorry, here you can write it as a to the power of n and its whole power m. If you can interchange these two exponents, then it cannot be factored its answer. So here we need to interchange the exponents of these two terms in the left hand side. So here we interchange these two exponents, and you can write it as 2 to the power of n and its whole cubed minus 2 to the power of n and its whole square is equals to 18. And in the next step we can change this nice exponential equation into the cubic form, so that here we will take y is equals to 2 to the power of n. So when you can take y is equals to 2 to the power of n, so this equation will becomes in the form of y cubed minus y squared is equals to 18. So it will becomes in this cubic form. So now we can solve this nice cubic equation. So here we move this 18 in the left hand side, and you can write y cubed minus y squared minus 18 is equals to 0. And we will rewrite this equation as, here you have y cubed minus y squared, here you have minus 18, and we can write this minus 18 as minus 27 plus 9 is equals to 0. And we can make the pairs of cubic terms and the square terms. So here you see that we have y cubed minus y squared, and we write this 27 as 3 cubed, and we write this 9 as 3 squared is equal to 0. So here you see that we have two cubic terms and the two square terms. So now we can make the pairs of cubic and square terms. So it will becomes y cubed minus 3 cubed, and here we take common minus sign from this and this term, and you will get here minus times of y squared minus 3 squared is equals to 0. And now you can focus on both of the terms, and you see that here we need two formulas. The one is cubic and other is square. So you know that these two formulas, if we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b square. And similarly we can write it as a square minus b square, it is equals to a minus b times of a plus b. So here we need these two nice formulas. So now first I can apply the cubic formula in the first factor, so that the first factor will be written in the form of y minus 3 times of y squared plus 3y plus 3 square, minus, here we can apply the second formula in this term, and you will get y minus 3 times of y plus 3, and this whole equation is equals to 0. So now you can focus on these both terms, and you see that we have y minus 3 be the common term, So we take common y minus 3 on both of the terms, and you will get here y minus 3 times of y squared plus 3y, plus here you have 3 square, and 3 square is equals to 9, minus here we take common y minus 3, and here you get y plus 3. So we multiply this minus sign on both of the factors, and you get minus y minus 3, and this whole is equals to 0. So now we can simplify the terms, and you write y minus 3 times of y square plus 3y, and here you have 3y minus y, so it is equals to plus 2y, and 9 minus 3 is equals to plus 6, and this whole is equals to 0. So now in the next step we can solve these two factors, and here we have two cases. The first case is we take y minus 3 is equals to 0, and the other case is we take y squared plus 2y plus 6 is equals to 0. And in the start of the question I can say that we need to solve this problem for the real roots only. So here we need only real roots. So now we can first check this quadratic equation has real roots or complex by using the discriminant formula. So now you know about discriminant formula. Here we have a is equals to 1, b is equals to 2, and c is equals to 6, and our discriminant formula is delta is equals to b squared minus 4 times of ac. And now we can put the values of a, b and c in this delta, and you check the behavior of this delta. So here you have 2 squared minus 4 times of a is 1, c is 6. So here you have 4 minus 6 times of 4 is 24, and 4 minus 24 is equals to minus 20. So here you see that our delta is less than 0. So if this delta is less than 0, it means that this a quadratic equation has no real roots. So if it has no real roots, then we can just rejected this case, because in this question we need only real roots, so that we will reject it this case, and we can just proceed here this case only. So in this case we move minus 3 in the right hand side, and you get y is equals to 3, and in the start of the question we will take here y is equals to 2 to the power of n, so that we will back substitute the value of y here. So you get 2 to the power of n is equals to 3, and in order to find the value of n we will take here log on both of the sides. So when you can take log, you will get here n times of log 2 is equals to log 3, and finally you can say that we have n is equals to log 3 over log 2. So this is the our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.